Hello, my name is Daniel Sallee, and for my Forestry 375 project, I did an analysis of snowfall across elevation gradients through time in the state of Idaho. My hypothesis was that areas of high elevation would experience less variation in snow presence over time than areas of low elevation. So to complete this study, I used 3 different data sets. The first was Pacific Northwest snow cover data. This was a simple raster file that contained cells with a value of 1 where snow was observed, and no data for all other places where there was no snow. I used a digital elevation model raster of the state of Idaho. This consisted of 6 separate raster files with 30-meter pixels for the elevation in the entire state. I then used a state line shapefile to constrain my analysis to the state of Idaho. So here's my model. It does seem a little complicated, but that's only because I had to process each of the 6 raster elevation models separately before I could do my analysis, and there's 9 outputs because this study was conducted using 9 years of data. So I reclassified the digital elevation data, converted it to vector data, merged and dissolved these vectors and clipped it to the state of Idaho, then used the zonal statistics as table tool to perform my analysis. I'll go over this in a little more detail. So first I reclassified the digital elevation model. I did this to simplify the analysis process and create elevation gradients where I can analyze the presence or absence of snow. I used 500-meter categories. For example, the 0 to 500 meter category, the 500 to 1,000 meter category, and so on through the 4,000 meters, which encompassed all the different elevations in Idaho. I then converted this to vector data using the raster to polygon tool. I did this because the format of the snow cover data made it impossible to do a solely raster-based analysis because of the no data values. I could not use that raster in the raster calculator for analysis because of these values, and the vector data made it much easier. So I merged the 6 separate vector elevation models into one, and then I dissolved this newly created vector shapefile. I did this to remove artifacts from the merge and also to simplify the attribute table. So this simplified the attribute table so that each row contained all the polygons in an elevation category, making the analysis very simplified at the end. So then I clipped this to the Idaho state boundary to constrain my study area. And then I used the zonal statistics as table tool to perform the bulk of the analysis. So what this tool does is it takes the elevation polygons and the vector data and extracts information of the raster data where they overlap. So so it counts the number of pixels that fall on each polygon and then performs statistics on them, such as an average, a median, and so on. I was only interested in the summation, so I just used the tool to sum the total amount of pixels in each elevation gradient. The output of this was a table, so I had 9 tables and I exported them to Excel to create this graph. So we'll go over the results of my analysis. So the 0 to 500 meter category did not have any snow in any of the years. The 500 to 1,000 meter category, seen here, fluctuated greatly across the study time. It had about 40 cells at its highest and down to 1 or 2 at its lowest, showing a lot of fluctuation. The 1,000 to 1,500 meter elevation class had a lot of fluctuation with both upward and downward trends throughout the study time. The 1,500 to 2,000 meter elevation class had the most snow total, but it did experience fluctuation as seen here. The 2,000 to 2,500 meter data had a very constant presence of snow throughout the study time. The 2,500 to 3,000 meter elevation class had the exact same amount throughout the entire study period, as well as the other 2 high elevation categories. So this does support my hypothesis that the areas of higher elevation will experience less fluctuation than areas of low elevation. In this case, higher elevation experienced no fluctuation in the presence of snow for each year, and the lower elevations experienced a lot more. So the reason that the 1,500 to 2,000 meter elevation category had the most amount of snow was because it had a higher proportion of area than all the other elevation categories in the state. So to conclude, my hypothesis was correct in that areas of higher elevation would experience less variation in areas of lower elevation. So thank you for watching.